Hello, my name is Talon Capoeman-Williams. I am currently at Cowling Creek in Suquamish territory. Today what we're doing here is we're looking at Cowling Creek and the tributary and the culvert here and what we can do to improve the stream health and what we can do to further help the salmon coming back. We have a data sheet where we record all of our information. Be sure to fill out all the information at the top of the data sheet, including the name of the stream, your school and team names, date, the road name, and other important information. Use your GPS to find latitude and longitude, or do this beforehand using your computer to locate your culvert. You want to determine the shape of your culvert. Circle this on your data sheet. Next, you want to take measurements of your culvert and the stream itself. Measure the length of the culvert. You will need a rolly tape and rubber boots or waders. This works best with at least 2 people. If the water is too deep or the culvert is too small to walk through, you can measure the length of the culvert from above. Next, measure the culvert span or horizontal dimension using a tape. Also measure the culvert rise or height of the culvert using a tape. Measure the slope of the culvert. This is also called the upstream gradient. Use a clinometer or use the string and line method to calculate slope. Measure the water depth in the culvert using a rod or measuring stick. Say like 5 1/4. Check to see if there's stream bed material in the culvert. It should be covering at least 50% of the culvert bottom. Make notes if there is debris blockage at the mouth of the culvert. Estimate the percent of blockage. Check for a rust line or scour in a metal culvert. Measure from the bottom center of the culvert to the approximate height of the rust line. For cement culverts, measure the height of the algae or moss growing inside the culvert. Measure of outfall drop. The distance from the culvert to the water surface of the pool below using a rod or measuring stick. Measure the depth of the pool at the lowest stream bed point within 5 feet of the culvert outlet using a rod or measuring stick. Using a tape, measure the length of the outlet pool. Take 4 photos using your camera or smartphone. First, facing the inlet. Second photo, standing at the inlet end facing upstream. Third photo, standing at the outlet end facing upstream. Fourth photo, standing at the outlet end facing downstream. Measure the upstream slope or gradient using a clinometer. Measure the downstream slope or gradient using a clinometer. Finally, note on your data sheet if you think this culvert is a barrier to salmon passage and why. You may also want to make stream measurements for water quality and salmon habitat suitability. Water quality monitoring can include measuring pH, dissolved oxygen, and temperature. 7, but I'm just scrolling. Thanks for watching, and good luck with your culvert inventory.
My name is Paul Dorn. I'm a retired biologist with the Suquamish tribe, and we're standing in the Cowling Creek estuary. Miller Bay is right behind me, and Cowling Creek is one of many small streams around the Salish Sea that historically had lots of salmon in. And I was fortunate to talk to tribal elders at the beginning of my career here. They used to harvest coho, steelhead, and cutthroat out of this stream. The culverts that Talon is studying are 2 36-inch barriers that are 100% blocks to salmon migrating upstream. And they're typical of many culverts around the Salish Sea. They're like slides. We call them velocity barriers because as a fish, as you enter and try to swim upstream, you run out of energy. Like if you're trying to climb up a steep slide, easy to come down, hard to go up. And to solve this problem, we need to remove the culverts. That's easier said than done. We looked at 3 options in this case recently. One was to tunnel under the road. That's expensive. Another option is to punch a larger culvert under the road. That's called jacking a culvert. And the third option, what is the most preferable in most cases, is build a bridge. And in this case, it would take about $4 million. So it's not something that's going to happen right away, but the community is working with the tribe, the county, and the state to find funds to replace these culverts to restore salmon to Cowling Creek. We had the Wild Fish Conservancy, a local mapping organization, mapped Cowling Creek watershed in 2010. What shows on our maps, if you look on a street map, is only about 40% of the entire watershed. So it's very important to know how big the watershed is, where the salmon spawn and rear, so that you can design bridges appropriately. And as the camera pans around and looks at the bottom of these culverts located in the estuary, where the saltwater comes up at high tide, you'll see wood, trees that have fallen over. That's nature's way of incorporating structure into the habitat, which is important for salmon and all the other wildlife that use this space. So many other projects are going on in this watershed. Trout Unlimited is building viewing platforms for visitors to see the salmon move upstream. Friends of Miller Bay is buying habitat, working with the Great Peninsula Conservancy, which is our local land trust, to set aside land for the fish and wildlife and for people. We build trails that you can use to walk through the watershed and learn about everything that lives here. So whether you're a small aquatic or stream bug or eagle or bear, they're all present and they all depend on the salmon here. So we hope you visit Cowling Creek someday, or a stream near where you live that has similar efforts going on. The only way we're going to recover salmon in Puget Sound is for everybody to work together to protect the habitat and restore access to this habitat by removing barriers. And your help's needed, and whether you're a biologist or not, it's important that we restore the natural world as much as we can. Thank you.